All right, so now we're going to do problem 3.5.12. The accompanying data set lists performance IQ scores from random samples of subjects with blood levels categorized as low, medium, and high. Use a 0.10 significance level. To test the claim, the subjects in the categories have the same median. So that would have to be D. It's the only one that has that in the null. Okay. Now, as soon as I look at the data here, I know we got a problem. The problem is that they're not in three separate columns. So we can open StatCrunch. Then what we want to do, also notice that lead and IQP are there. And what we'll do is we'll just take the data that has a level 1. We'll Control C. We'll put it in variable 3. And we'll go over and copy all the IQs that were level 2. Control C. Put those in variable 4. Control V. And then lastly, we'll get all the ones for variable 3. Control C. So there's 51 of them altogether. Control V, because I don't count the first row. So let's double check. So in variable 5, we have 9, 10, that's 19. And in variable 3, we have 32. 1932 is 51. So we have the right number. So now when I go to stat, non-parametrics, Kruskal-Wallis, I want to do variable 3, 4, variable. There we go. Variable 3, 4, and 5, and compute. And I'm going to open up this bigger. We don't need the data anymore. We need the StatCrunch readout. So the test statistic is 10.12. All right. And the p-value, which I didn't look at yet, it's 0.0064. So 3 decimal places, 0.006. Well, they always change the number of decimal places. You got to be careful with these guys. So we're less than 0.10. That was the alpha. Where is it? There it is, 0.10. So we're going to reject the null. There is sufficient evidence to reject the claim. We're rejecting the claim, which is in the null. And that was that they had the same median. Okay, so there you go. So for that one, it was resorting the data. Looks like that's what's going on for a lot of these, just resorting the data and making it so that you can use it effectively. Okay, so Dr. K.